So in this video, we're going to look at the undetermined coefficient method when the driving function happens to be a solution of the homogeneous differential equation. So it says determine the form of the particular solution for y double prime minus y prime minus 6y equals 2e to the 3x. And we're given that the complementary solution is c sub 1 e to the negative 2x plus c sub 2 e to the 3x. And this comes from the fact that the characteristic polynomial looked like r squared minus r minus 6 equaled 0, and it factored as r minus 3 and r plus 2. And so we have the roots of the polynomial up in the exponent position on the exponential base e. And so the problem that's going to arise here is the driving function 2e to the 3x has as its coefficient a 0-degree polynomial or a constant. And so what we would like to guess for y particular, we'd like to guess that it's going to be some scalar a times e to the 3x, that our particular solution is going to have this form. And the problem is going to be that our complementary solution has c sub 2e to the 3x, c sub 2e to the 3x as part of its form. And what this tells us is that c sub 2, a constant, times e to the 3x is actually a solution of the homogeneous differential equation. So that means if we guess the y particular is a e to the 3x, when we take and plug y particular and its derivatives into the differential equation, it will zero the equation out. So the question is, what do you do when you notice that the solution to the homogeneous differential equation has as one of its two pieces the driving function? So in other words, the driving function 2e to the 3x is a member of this vector space right here. It's a member of this solution space because it has the form a constant times e to the 3x. So the way that you deal with this is pretty straightforward. What you do is just modify your guess. Instead of guessing a constant times e to the 3x, we'll just make a guess that our particular solution looks like a times x e to the 3x, and then we go through the solution process making this guess, and this will work out if you push this guess through this differential equation. If we get a situation like this, so here I have y complementary is c sub 1 e to the 2x plus c sub 2 x e to the 2x. And that comes from the fact that our characteristic polynomial for the homogeneous differential equation was r squared minus 4r plus 4 equals 0. And this actually winds up having the repeated root r equal to 2. And so the solution when we have a repeated root is that we get c sub 1 e to the repeated root times x plus c sub 2 x times e to the repeated root times x. So this is case number 2 from our solution process for homogeneous differential equations that we looked at in the previous homework assignment. So this again is a case where the driving function is a member of this solution space. It's a constant times e to the 2x, a constant times e to the 2x. So if we make the guess that y particular is a constant multiple of e to the 2x, this would zero this differential equation out. So we do the same thing that we did in the previous example. We modify our guess so that the particular solution looks like ax e to the 2x. But then when we look at this, we realize that this, as a guess for the particular solution, is also a member of the solution space for the homogeneous differential equation. So if we plug in ax e to the 2x and its first and second derivatives, it will also zero out the homogeneous differential equation. So in this case, we just then step up our game one more time. We change our guess to ax squared e to the 2x. So we just keep adjusting this x term up a degree as necessary, depending on whether the guess that we're making is a member of the solution space or not. Once we get a power of x that causes our particular solution guess to no longer be a member of the solution space, Then we go ahead and we take the first and second derivatives and plug it in and do the same things that we did in videos 2, 3, and 4 for finding the particular solution to the differential equation, or I should say a particular solution to the non-homogeneous differential equation.